All right, hey guys, this is my first attempt to actually teach you something over Google Classroom. So I'm going to try and keep this to under 10 minutes, and I only have 15, so it will not be more than 15 minutes. So before I even get started, I want to go over some objectives. First, I think it would be very helpful for you to number your pages. I've numbered my pages of my packet. So the first page is number 1. I flip it over to the periodic table, open number 2, and then number 3 was that first coronavirus article, and so on and so forth. I'll be referencing page numbers. I'll also give you good titles of the worksheets that I'll be referencing. So if you don't have them numbered, it's not a big deal, but I think that might be helpful. Number 2, I'm going to have a forum up on Google Classroom just to see who is actually able to view my videos. This isn't like a gotcha thing. I just want to know who is able to view these videos and who do I need to get material in a different way, because I'm working on doing that. I know not all of us can view these videos, so I'm working on that. If you know of someone who is not able to view these videos, please let me know so I can be in contact with them and so I can be figuring some things out, because I do not know how long we'll be out. Number 3 is the discussion post. That's your first assignment. It's assignment number 1 on your packet. I will post a new post this afternoon for you to comment on, and that will be a grade. If you choose not to comment, you just need to write a 100-word reply on a separate sheet of paper that can be turned in when the rest of your work is turned in. Number 4, I'm going to give you notes on Avogadro's number, molar mass, and I actually didn't get to intros to conversions, but that's a review of chapter 2 if you remember anything from chapter 2 on those conversion factors. Number 5, we're going to go over some examples together. I also gave you about 3 examples, I believe, in the packet already, and I'm going to go over 2 more with you from the packet. And after today, you should be able to complete assignments 1 through 5. So let's go over what the mole is. So a mole is just a way of measuring particles, okay? So we can't count particles because particles are tiny, so we've come up with the mole as a way to count particles in a different way. So a mole is just equal to 12 grams of carbon, and we may recognize that number. So where does that 12 grams of carbon come from? Well, if we look at our periodic table, carbon has the atomic number 6, and if we look at this number here, this is our what? You should pause me and you should answer this question. That's right, that's our atomic mass in grams, right? So this is typically in the unit atomic mass units, but when we talk about the mole, a mole is just essentially the atomic mass in grams. So a mole is actually 12.011 grams of carbon, okay? A mole is also equal to 6.022 times 10 to the 23rd particles, and this is known as Avogadro's number. So this is a lot of particles, right? Okay. So depending on the atomic mass depends on how much each one of these particles weighs, right? So the larger the particle, the more a mole will weigh for a specific element or compound, okay? So when we talk about the mole, we're just talking about a way of measuring things. So it's just like saying a dozen flowers, a dozen whatever. So if we ask the question, what weighs more, a dozen bricks or a dozen feathers, the answer is kind of easy, right? A dozen bricks is going to weigh more, right? Okay, a dozen bricks weighs more than a dozen flowers. Even though we have 12 bricks, 12 flower or feathers, we have the same number. But they have different masses, right? So how exactly do we find the molar mass of an element? Okay, and you can pause me. I know I'm talking very quickly, and I would suggest you pause after each one of these examples and you try and do it on your own. So we'll do the first one together, but we've already kind of done this, okay? So 1 mole of carbon. What I have sitting in front of me right now is my periodic table. You should have a periodic table in your packet, or you can just pull it up on your phone. Okay, 1 mole of carbon. I know that a mole of a substance is just the atomic mass in grams. So 1 mole of carbon, I look for the atomic mass. Carbon is number 6 on the periodic table. I see the atomic mass is 12.0111 grams, okay? And forgive me if I misspeak. I'll have to go back and watch this and make sure nothing's crazy wrong, but it's very possible that I misspeak on some of these things. Number 2, 1 mole of sodium. How about you do that one? So pause me now. You try and figure out what 1 mole of sodium is. Okay, I'm going to keep going. 1 mole of sodium, I go, it's number 11 on the periodic table, and the atomic mass is 22.98977 grams. That's 1 mole of sodium. Okay, we can do the same thing with lead. Lead, find that on the periodic table, pause me. All right, lead is number 82 on the periodic table. The atomic mass is 207.2 grams, so we have 207.2 grams in 1 mole of lead. Okay. Now, when we get into converting more than 1 mole of a substance, all we have to do is multiply it, right? So go ahead and predict if 1 mole of carbon is 12.0111 grams, we know 2 moles of carbon would just be around 24, right? I think. So we just do 2 times 12.01, and I just did some rounding here, and got 24.02 grams. Okay, we can do the same thing with number 5, and pause me if you need to, okay? And please do, actually. 0.75 moles of sodium. What do we do there? Well, we just multiply the atomic mass of sodium times 0.75, and we get 17.235 grams. Okay, so look up here. 1 mole of sodium is 22.98977 grams. Not quite 1 mole of sodium is going to be not quite the atomic mass of 1 mole of sodium. Do we see how 1 mole weighs a little more than 0.75 moles, right? Okay. Now, that's just finding the atomic mass of elements, okay? What we'll find the atomic or the molar mass of is typically our compounds. So we have a compound here. This is potassium chromate, okay? We know we have potassium and we have CrO4, which is chromate. Hopefully you remember those polyatomics. If you don't, be reviewing those. We have to look at how many of each element do we have. So how many potassium do we have? We have 2, right? So we're going to multiply it by 2. How many chromate do we have? We have 1. We can multiply it by 1, or we can just keep it the same. And how many oxygen do we have? We have 4. So I'm going to multiply, and this should be 15.999 grams. I shouldn't have rounded so early. Okay, so maybe we shouldn't round as early. Okay, I multiplied those numbers. I get these numbers, and what do we do with these numbers here? We just add them together. Okay, we're going to add those together, and the molar mass of this compound is 194.20 grams. That's how many grams is in 1 mole of potassium chromate. Okay, if we think about this like baking a cake is not just the flour, it's not just the sugar, it's the flour and the sugar and the baking soda and the baking powder, and I don't really know how to bake a cake, so I'm just naming ingredients that I think's in cakes, but just like in a compound, it's not just one element, it's all the elements combined together to get the total mass. Just like when you bake a cake, it's all the ingredients together to bake that cake, okay? So we're going to do 2 more examples, and bear with me as I switch between things. Oh, that was a lot easier than I thought. Okay, so we're going to do sodium carbonate and calcium hydroxide, and this is on page 13 of your packet if you numbered, okay? And you can pause me now if you can't find it. It's also labeled molar mass worksheet key. Okay, it says for the following compounds, write the chemical formula and determine the molar mass. Okay, we're going to write the chemical formula together, and we're going to find the molar mass together. Okay, you still need your periodic table, so have that close by. Okay, we're going to do sodium carbonate and calcium hydroxide. Both these contains polyatomics. Okay, and you can pause me if I'm going too quickly, but I am going to go through this as quickly as possible so this doesn't turn into a really long video. Okay, so we got sodium. We know sodium is Na, and oh, this is so hard to do. Na has a charge of 2+. Am I right on that? Uh-oh, I don't remember. This is giving me mush brain. Oh, I'm wrong. Okay, hold on. This has a charge of just plus. Y'all haven't done this in forever. Carbonate is CO3, and God, Andrew, tell me if I'm wrong on these things because I haven't studied this in, a week now. These things do a little switcheroo. All right, so we get sodium has a subscript of what? Okay, it should be 2 because the subscript comes from the charge on carbonate. And carbonate has a charge of what? Very good. Carbonate has a charge of 1. Okay, so it's just Na2CO3. So what are we going to have? We're going to have 2 parts sodium. Okay. So we're going to do 2 times the molar mass of sodium, which we know is what? Look on your periodic table, maybe pause me. It's 22.9. I'm going to just call it 22.9. And should I be rounding? No, but it's so hard for me to draw on this thing. I hate it. Okay, we have a part carbon. How many? Just one. We know that one carbon is just 12.01. Okay, and then we have oxygen. Oxygen, how many parts do we have? We've got 3. 3 times, what are we multiplying it by? We're multiplying it by the atomic mass of 1, which is 15.999. Okay, I would put 99. Okay, and then we're going to multiply those things and then add them together. And I'm going to pause myself so I can do the math. You should pause me so you can do the math, okay? And I'll be right back. Guys, I'm back and I'm learning. Look at this. Okay, so I multiplied 2 times 22.9. I got 45.8 grams. I know that we just have 1 carbon, so 12.01 just stays 12.01. And our oxygen, we have 3 times 15.99. I got 47.997 grams. Okay, now what are we going to do with these numbers? We're just going to add them up, okay? So I'm going to pause. I'm going to do a math, and I'll be right back. Once you add them up, you should get 105.897 grams. And now that's a little off, and why is that off? Because I'm lazy and I rounded. I rounded here, I rounded here, I rounded here, and that was only because it was so hard to write on this thing, y'all. The actual atomic or the molar mass of sodium carbonate is 105.988 grams per mole. So this is the number of grams in 1 mole of sodium carbonate, okay? So if I measured out 1 mole of sodium carbonate, or if I wanted 1 mole of sodium carbonate, I'd measure out 105.897 grams on a scale, right? Okay, and that gets into how we prepare solutions. Now let's do calcium hydroxide, and this will be the very last thing that I do. Okay, and then you can do assignments 1 through 5. All right, calcium hydroxide. All right, it's made up of 2 parts, and let me see. Oh no. Okay, give me 1 second. This is very hard to figure out, y'all. So calcium has a charge, and I'm looking at my periodic table. Oh my goodness, why is my pen not writing? Calcium. Y'all, I'm gonna lose it. Wow. Okay, calcium for the 4th time has a charge. There it is. Look at me go. Calcium has a charge of 2 plus. All right. And hydroxide is a polyatomic. We know it's OH, and that has a charge of what? That's right, class, minus. This is the weirdest thing to be doing right now. So calcium is Ca parentheses OH 2. There we go. All right, now let's set up the same thing that we did over here. How about you do that on your own? And I'll come back and I'll have that for you. So pause me right now, okay, so that you don't see these answers because they're going to pop up really soon. All right, we should know with these numbers here. We can multiply them, right? Okay, and then what are we going to do with them? We should add them, right? Okay, let me give you that step by step. So pause me here. I'm not sure I explained that well. Calcium, we multiply it by 1 because we have 1 calcium. Oxygen, we multiply it by 2 because we have 2 oxygen, and hydrogen we multiply by 2 because we have 2 hydrogen. I'm getting all these numbers from our periodic table, the atomic mass units. We multiply those numbers, we should get these numbers, and then what do we do with them? We add them up, and what do you get? I got 74.094, and that is it, y'all. Okay, so you should be able to do all assignments 1 through 5. Okay, let me see if I can get back here. We went over all the examples, and I think we are good, okay? If you have any questions, please reach out. Please comment on the video below, not on YouTube. Comment on Google Classroom, please, so I can answer those. I won't see them if they're on YouTube. And finally, I'll be posting 1 more video this week, and that'll get us through this entire packet. People keep asking me what the plan is. I have no idea, y'all. I'm just doing what they tell me to do, and I'm trying to make sure that you guys learn something. So stick with me. If you're having trouble, be there at the Facebook Live. I will, not even kidding, be doing karaoke. So I will see you all then, or maybe not. I don't know, gal. We'll see. Stay safe out there. Wash your hands.